My dear viewers, now discuss S block element group 1 and group 2, that is alkali and alkali earth metal. Okay, now discuss only for the 15 MCQ with explained. Okay, now that group 1 alkali metal, lithium, sodium, potassium, rubidium, cesium, and francium, alkaline earth metal, that is alkaline earth metal. Group 2 beryllium, magnesium, calcium, strontium, barium, and radium. In all the group 1 and 2 we follow the pattern 8 8 18 18 32. That is the first element, atomic number 3. The pattern follow 8 8 18 18 32. That is 3 plus 8 11 sodium. Similar way, group 2 Be beryllium, 4 plus 8 12, that is magnesium. Follow the similar pattern 8 8 18 18 32. Okay, now discuss the question number 1. First question: which of the following metal is not an alkali metal? Magnesium is not an alkali metal. Okay, alkali metals are the elements of group 1, the outer of the cell electronic configuration group 1 in S1. Okay, but the magnesium electronic configuration in S2, that is alkali earth metal. Okay, that is alkaline earth metal or group 2 element electronic configuration. Okay, now the question 2: alkali metals have the biggest atomic radii. This statement true. This statement true, because the alkali metals have the biggest atomic radii in their respective period. Okay, atomic radii increases as we go down the group due to the additions of a new cell in its subsequent states. Okay, so the above the statement is true. Okay, now the next question: the melting point of alkali metals is low. That is option 2. Now the melting point and boiling point of alkali metal are quite low, and they decrease down the groove due to the weakening of their metallic bonds. But the magnesium is liquid at the room temperature. Okay. Also, magnesium is a radioactive element in group 1, that is alkali metal. Okay. Next question: is there removal of second electron difficult in the alkali metals? This statement is true. Okay. Now, the first ionization enthalpy of alkali metal is the lowest among the electrons, that is the outer of the cell. They easily remove of the outer of the cell. Okay. This, but the second ionization enthalpy of the alkali metals are very high, because releasing of an electron ions require the noble gas electronic configuration. Okay, so now they explain the sodium electronic configuration: 1s2, 2s2, 2p6, 3s1. Okay, but the before 3s1, the 2s2, 2p6, that is the noble gas electronic configuration. Removal the outer the cell, that is the electronic configuration of noble gases, it is very tough. That is why that is why second electronic difficult is the alkali metal. It is the second electron removal, it is very difficult. Okay, next part. Now the next question. Now the question number 5: alkali metals are very strong, the electropositive. Okay, due to the electronic configuration of alkali metals in S1, the outer of the cell number of electron 1 is very easily removed. Okay, that is why so the electropositive. Okay, due to the low ionization enthalpy, alkali metal are strongly electropositive, or alkali metal, that is the metallic in a nature, and the electropositive nature increases from lithium to cesium due to decrease in the ionization enthalpy. Okay, this is the point, is very most important line. The increase from lithium to cesium due to the decrease in ionization enthalpy. Okay. Next, next question. Alkaline earth metals show plus positive oxidation state and their atomic volume dash down the groove. That is the option C, decrease. Okay. Due to the inertia, alkali metals atoms show only the plus one oxidation state because of their unpositive, that is the unipositive, that is single positive, unipositive ions at their time the stable noble gas electronic configuration. Okay, the atomic volume of the alkali metal is the highest in its period and goes on increasing down the groove from top to bottom. Okay, next question, question number 7. Does the degree of hydration depends upon the size of a cation? That is, statement is yes. Okay, now I explain this part. The degree of hydration depends upon the size of cation. Smaller, smaller size of the cation, greater is its hydration enthalpy. So the group 1 relative the degree of the hydration in an increasing order, lithium ions greater than sodium ion, greater than potassium ion, greater than rubidium ion, that is the lowest part of the last part of the cesium. Okay, next part, this is the question number 8. The flame of the cesium is in the color option D, that is blue color. Due to the ancient alkali metals and their salt impart the characteristic color to the flame because the outer electron get exit to higher energy level. Okay, when the electrons return to the original state, it releases visible light to the characteristic wavelength which provide color to the flame. The color of the flame of the cesium is blue. Okay, next question, question number 9. Cesium has the highest electrical conductivity in its group. This statement is true. Okay. Due to the presence of losing held valence electrons which are free to move throughout the metal structure. Alkali metals are good conductor of heat and electricity. Okay. Electrical conductivity increases from top to bottom in the order. So, cesium has the highest electrical conductivity in its group. Clear, my dear viewers? Next question, question number 10. All alkali metals are good dash agent. That is, a reducing agent. Alkali metals, that is the electronic configuration NS1, that is the outermost electron number of electron 1, it is very easily removed. Okay, that is the reducing agent. That is why now they explain this part. All the alkali metals are good reducing agent due to their low ionization energy. Low ionization energy, the reducing character of group 1 element follow the increasing order of sodium, potassium, rubidium, cesium and lithium. Okay. Next question, question number 11. What happens when alkali metal are exposed to moisture air? Okay. That is the option B, formation of oxide. Formation of oxide. Okay, due to the expense part and on exposed to moisture air, the surface get the terminated. due to the formation of oxide. Formation of oxide. Hydroxide and carbonate. Few example: sodium hydroxide, sodium carbonate, potassium hydroxide, etc. Main point, that is the answer formation of the due to the formation of oxide. Okay, at the presence of moisture. Okay, next question, question number 12. Sodium peroxide is dash in the color and the potassium superoxide is used as the source of dash. That is the option D, yellow and oxygen. Oxygen. Okay, that is the first. Sodium peroxide is yellow in color. Yellow in color. Okay, and the potassium superoxide is used as a source of oxygen. Okay, that is potassium peroxide used in the submarine. Okay, now I explain this part. Sodium peroxide acquiring yellow color due to the presence of superoxide. Okay, as in impurity. Okay, potassium superoxide is used the source of oxygen, submarine, space satellite, etc. Okay. Next question, which of the following is true regarding the reactivity order of alkali metal towards hydrogen? Okay, the reactivity series for the alkali metal group 1, that is lithium less than sodium less than potassium less than rubidium less than cesium. Okay, it is the most important order, okay, for the reactivity order, okay, towards oxygen, not hydrogen. It is the reactivity series, that is the hydrogen. Next question, that is now discuss this part. 2 moles of alkali metals react with 1 moles of hydrogen molecules in order to form 2 molecules of alkali metal hydride. According to the order reactivities of alkali metals towards hydrogen, not oxygen, towards hydrogen, lithium less than sodium less than potassium less than rubidium less than cesium. Next question, question number 14. Lithium fluoride is dash in water, that is insoluble in water. Okay, insoluble in water. All the alkali halides except lithium fluoride are soluble in water. This is because lithium fluoride LiF is soluble in non-polar solvent as it has a strong covalent compound. Okay, lithium fluoride is so the character of covalent compound. Okay, next question. This is the last question of this part. That is question number 15. Alkali metals dissolving in ammonium liquid, that is ammonia liquid, give the blue solution. This is due to the formation of ammonia, that is the option C, metal cations and electrons. Okay, now discuss for this part. They give the deep blue solution due to the formation of ammonia, the metals cation and electrons. Okay, the blue color is due to the oxidation of ammonia electron to higher energy level and the absorption of photon occurs in the red region of the spectrum. Okay, my dear viewers, please take this note of the PDF form. Please show the description box to take the PDF form. Okay, thank you, my dear viewers. Thank you.